Thank you. Okay, so hello, good morning, all. My name is Deepak, and I see a few participants who have joined. So, my name is Deepak, and I'll be taking you through this session for the next 1 hour. And just to brief introduction of myself, I have been working on the Java and J2E and related technologies for the last almost 18 years. I have a huge industry experience on Java and related technologies. I started from core Java and now currently working on the latest on the cloud applications. So that's a brief introduction of myself. And today I'll be discussing about some of the core part of the Java and how it is mapped to the industry. So we'll see how Java is taken today in the industry and what are the features in Java, especially in the Java 8, which has been added in the recent, and how these features can be leveraged. And some of the internal things of the Java JVM architecture, just for you to understand how Java is structured and what are the changes in Java 8 or enhancements which they have done. So, and some of the best practices and industry standards and the tools used in the industry for these things. So basically, we'll touch upon how we can take up to this core Java to the next level when we actually work on the projects, and what are the actual problems that we encounter when we work in the actual hands-on project. So we'll touch upon some of the overviews of those things. I'll share my screen and we'll start the session. Before I start, I just want to understand anyone who has joined does not have any programming background. You can just ping me, or you can unmute yourself and talk in case you're not worked on any of the programming languages. Okay. So if so, then I'll assume you guys have the programming background. Anyone has not worked on Java or does not have basic concepts of Java. Okay. So I'm assuming that you guys have the basic knowledge of Java, and so with that assumption, I think we can start with our session. So yeah.
Deepak, just a minute. Guys, if anyone has to, if anyone wants to interact with Deepak, our instructor for the day, you guys can use the chat window or you can directly unmute yourself and interact with Deepak. All right. So let's keep the session interactive. More people will be joining. Thanks. Please continue, Deepak. Yeah.
Thank you. Okay, so let me share my screen. So I have few contents to show, but this is just for the representation, but we'll talk more on that. Okay, so I hope you guys can see my screen.
Yes, Deepak, we can see the screen.
Okay. So just have put a few details on what on the right hand side what we'll be discussing, on the left hand side what will be the actual course content. So if you see right, the course what we're talking about contains all on the industry standards and the industry based use cases. On the right hand side, today what we'll discuss is we'll just have a quick touch point on the key features of Java 8. So as you know, Java has evolved many years, started from 1994, where Java's first release version was released, and till date Java has undergone many changes. It has seen lots of ups and downs, and still it is one of the key leader in the market today. And the current version of Java is actually Java 9, which is actually used in some of the latest project in the industry. But Java 8 is more standard version, which is most of the production environments of the projects is running on Java 8. Slowly, once the changes or the upgrades happens, things will move to the next version. But Java 8 is the currently most stable version, which is used in the industry as of today. So today we'll talk about the key features of Java 8, and then we will also touch upon the JVM, Java Virtual Machine. So we'll see how the architecture of the JVM has undergone changes in the Java 8 compared to the previous version. I think this is the most important part which all needs to understand. Because this helps us once we understand the JVM architecture, right? So JVM is Java Virtual Machine, in case you're not aware. This is the core part of Java. So once we run the code, if we have to run the write the code, if we have to run the code, we need a JVM, a virtual machine. A virtual machine will be running on any operating system. It will be utilizing the operating system resources to run our program. And this JVM is the one which makes Java platform independent. Okay, so which can run on any operating system. So that's a unique feature of Java, as you guys might be aware. So we'll touch upon some of the key concepts of the architectural changes of Java Virtual Machine. And then we will also see some of the design patterns which is used widely used in the industry, and some of the best practices. So we'll touch upon what are the key problem areas whenever a person works on a Java based project in the. So usually what happens is in the core in the when we learn Java, we always learn the core Java part, and then we write some basic programs. But when we work on the projects, the live projects, it will be a totally different experience. I've seen people who struggle. They would be good in the conceptual or the writing the code, but when they are put into the live projects in the companies, and they struggle to write the best code, because there will be lack of awareness of what the industry best practices are, and how it can be leveraged, or how the code can be tweaked or written, which aligned with the industry standards. So we'll touch upon those things. And the other problem which I've seen is troubleshooting. So writing the code is one part, which once we have the design, so we write the code in Java, and then the most tough part of I've seen people struggling is in troubleshooting and debugging techniques. So they lack the skills of troubleshooting and debugging, which is very important part when we are working on any projects. So always the success is measured how fast or how quickly we can troubleshoot or debug the code or the application which we have written. So we'll touch upon some of the troubleshooting and debugging techniques to understand, how better it can be done. And we will take upon, the last we'll see if any question and answers are there. So any questions so far from anyone? You can unmute or you can ping me in case you guys have any questions before we go to the next. Okay. And in case you guys are not understanding whatever any words I use, any because I'm assuming that you guys have a little bit of understanding of Java, but don't hesitate to ask questions in case you guys have not heard any of the terminologies of the words before. Please feel free to ping or ask, unmute yourself and ask the question. So don't hesitate to ask any questions. So there is no boundaries. So you can ask any questions. Any basic questions are also welcome. Okay. So let us move to the next slide. So this is just to cover on the overviews. Okay, so where all Java is currently used today. Okay, so I've just put this slide to give you an overview of how Java is placed in the industry. As I told before, once the Java was there in the 90s, started in the 90s, and it was with Sun Microsystem, a company called Sun Microsystem, which was the parent company for this Java. And then Oracle software, they took over Sun Microsystem, and currently Java is a product of Oracle company. Okay, and they are managing the updates and versions for this Java. And Java is widely used today in multiple areas. How if you see the history of Java, right? It started with core Java, then it came to the advanced Java. In advanced Java, you have J2EE Enterprise Edition, which contains the web technologies and the middleware. So all the layers have been added on year to the Java version. So currently, if you see Java, it is used in almost all the areas. When I say almost all the areas, whether it is a COTS product, okay, so when I say COTS product, it is called commercial off the shelf product. These COTS products are currently being used or adopted by the industry. So what this COTS product means is it has some inbuilt features. So what they use is I build a product to fulfill some of the specific requirements of the customer, and I develop this product, and I will make the developer's job easier. So I will have less coding available for the developers, and developers would be able to utilize some of the features of the product, and then enable the faster development life cycle of the application. So there are many COTS product available today in the market, whether it is a BPM, a business process management, and lots of COTS product. And these COTS product are, most of the COTS product are priced, so it comes with a price, but it allows faster development time. Why I'm saying this is these COTS product also leverages Java. Okay, so the underlying technology where these products are built on, it uses Java as their fundamental or a basement foundation structure. So we'll not talk more about this COTS product. I think once you start understanding how this industry has evolved. So when we talk about that, so I'll touch upon a few things, very basic things on the COTS product. And the next, you would have heard about this microservices. In case you have not heard, microservices is a methodology or a framework, okay, which is currently trending, I would say. Okay, so this microservices is a latest buzzword. Wherever you go, you hear about this microservices architecture. It is not something new. It is just a different way of performing my tasks. So I used to write a Java program before, and these microservices, what it does is it gives us certain standards and guidelines for me to write the Java code. That's what these microservices are about. So these microservices are a new standards or the frameworks or the pattern, whatever you call, which is currently being widely used in the industry. So these microservices are built on it's a service which is exposed, a lightweight, a small service which does a particular task. And these microservices are also, Java is also heavily used for this microservices framework or the architecture in the industry today. And ML and AI. So There is a typo there. It is ML and AI. So machine learning and artificial intelligence. If you are aware, these machine learning and artificial intelligence are the again new things which are it's not a new, actually it was there from before, but now it has taken the traction. Even for machine learning and artificial intelligence, you see Java as one of the key programming language which is being used today. And even in the big data, if you have heard about the big data, Hadoop, where you work with sorry, any questions from anyone? Can you guys go on mute in case you're not talking?
Yeah, Deepak, you can continue.
Yeah. Okay, so big data is where we have this Hadoop and all. If you have heard about that, it all works on the data analytics part. Sorry, the big data, the data managing the data part, and the cloud. So cloud is another new latest thing, which is just 1 minute. Let me say, I got a ping from the chat. Okay, so we have this cloud. So even in the cloud technologies, we are being using Java heavily, and IoT. IoT is Internet of Things. So this is related to the devices where you have a device. Now IoT is heavily used in any industry. Say, for example, you have a device in a car which is communicating with your location service system, like to track where your car is moving. So there will be a device which will be there in your car, which will be sending some data over the network, and there will be a server which will be receiving the data and making some analytics from the data. So this IoT, again Java is being used in IoT. So this is at a high level. Just wanted to give you a brief view of where all Java is used today. So it is used across all the width and the depth of all the latest industry use cases. Any questions? So if you guys have any questions on this, or if you want to know more about any of these things, you can let me know. Otherwise, I'll go to the next topic. Okay. So let me move on. Let's go into a little bit in depth of today's session. So I'll quickly cover on some of the key features of Java 8. Okay, so there are many, but I selected few which are key features which have changed in a huge way from the previous version to this version. So the first one is the lambda expressions. So what is this lambda expressions is, just to give you a background, before Java 8, if we had to write any functionality without a function, or whenever we want to implement or override a particular function which is defined in an interface or an abstract class, we used to override it by declaring the method and then providing the body for that method. So what this lambda functions does is, lambda functions provides an implementation for the functional interface. Okay, so what do you mean by a functional interface? Again, it's a new thing which was introduced in Java. So this is declared within an interface. A functional interface is declared within an interface. So before, if you yeah, sorry, any questions? Okay. So before, if you see Java 8, correct? So there were interfaces were not having any methods which has body. But starting from Java 8, they have given that feature of having the interfaces which can also have a method which has a body. So, any one of you are aware why the interfaces were not having, or why methods were not allowed to have a body within an interface before, and why Java 8 has provided that functionality of writing the body within the method? Anyone can answer? Okay, so I'll just tell that. So before in Java 8, right, you are having the methods in an interface. When you write a method, you are not having the body because to avoid the diamond problem. Not sure if you heard about the diamond problem, where if one class implements more than one classes, then there could be a problem where the implemented class overrides a method which is defined in both the parents. In that case, your runtime will not know which method to call of the parent class. So there could be a duplication. So to avoid that, Java was not providing a way to write a method body within an interface. And if you see, right, in Java, you cannot extend more than one class. You can extend only one class at a given point of time. But when it comes to interface, you can extend or inherit more than one interfaces. That's the reason why it allowed to inherit more than one interface, because interfaces methods didn't have a body, and writing the body of those interfaces were the responsibility of the class who has implemented those interfaces. This was to avoid the multiple inheritance problem which we could face. And but in Java 8, they have given the body for the method. So they have allowed the interfaces to define the body. That is because it will avoid the backward compatibility. Like, if you want to write some classes, even to today, right? If you add a new method in an interface, what happens is it gives an error in all the implemented classes. Agree? So in an interface, I have two methods, and my class A and class B will implement that interface, and you know that we have to override those methods. But if I make any changes to the interface, then it impacts all the classes who has implemented that interface today, right? So, but going forward, in Java 8, you have a feature called default functions. So using this default functions, you can avoid this. You can add a new method in the interface, and this will not impact any of the subclasses. It will not ask you the subclass, to override those methods. So those feature have been also added in Java 8. So we call it as a default methods, and static methods also can have a body within the interface. So lambda expressions are a way where you can write the body for the function without defining the or without overriding the function. So it is just like an inner classes. If you are aware of the inner classes concept, it is similar to the inner classes where,
Bharat, one question.
yeah.
Actually, I'm not understanding that point. With in the interface, we have two methods. In the class A is implemented class B, and the class C is implemented class B.
Mm.
Okay, at that time, is there any modification in interface? How it will impact in the classes?
No, no. Okay. So what you're telling is multi-level inheritance. So, like, say, consider an example where you have an interface with a
Yeah.
method called A. Okay.
Okay. Okay.
Let me just write it down. Can you see my screen?
Yeah,
Okay, I'm sharing up.
it's not visible. It's coming blank.
Okay, let me just. Can you see now?
Yeah.
Okay, so what I'm trying to say is you have an interface. Okay,
Okay. Okay.
let me call it as interface, and then say you have a class which implements, say, two classes which implements that interface. Okay,
Okay.
so now if you have a method called a here.
Okay.
Okay, so if you have a method called a, and in this particular this thing, right? So here also he has to override the function a, so method a, and provide the body, right? Because he has implemented the interface, right?
Okay.
So now this is all good, and it goes to production and everything is running fine. Now I think that no, I want to add one more method here called b. Okay, so once I add this method b, it throws an error here. It throws an error here, and it
Yeah.
throws an error here because
That add unimplemented methods.
yeah. So it says that you have to override even b method also.
Okay.
Right. So this is a very simple case, but usually in production, we will have interfaces which are what do you say, which are exposed uh, to multiple classes. So there could be hundreds of classes which are implementing an interface, and the impact could be very huge if I have to go and update all the classes, inherited classes, to override this method. So that problem is actually solved in Java 8. You can that's what it says, that you can have the feature of backward compatibility, where you can preserve the already implemented classes without impacting them, giving them
Okay.
backward compatibility, but also providing any new classes which implements my interface to provide the body for the newly added methods
Okay.
without impacting the old classes.
Okay.
Okay. So these are the key features, a couple of key features: lambda expressions and the default and static methods which are within the interfaces, and also for each. For each is basically for the collection. So previously, we used to use something called iterator. Let me know if you have not heard or used that iterator interface. So iterator interface is used to loop my collection objects. Okay, so collection objects, it could be a hash map, or hash table, linked list, or so any objects, right? If I have to loop through those objects which is stored inside those collection, usually I'll make use of an iterator object. So I'll create an instance of an iterator object, and then using the iterator object, I'll say iterator.next, and then get each element which is stored inside the collection objects. So there are some of the disadvantages of iterator objects, where the iterator objects will fail. It is basically synchronized, means only one person can work on the iterator object at a given point of time, because it holds those threads, and the other threads should wait until and unless one thread is making use of this iterator object. So that actually that drawback, or that feature is overcome using the for each. So for each gives a better way of looping the collection objects compared to the iterator, and it is very easy to code compared to the iterator, and also it overcomes that concurrent iterator object throws a concurrent exception. if multiple threads try to access the iterator object at a given point of time, it throws a concurrent modification exception. So that is avoided using the for each. So this is one of the other key feature which you can see in Java 8. And some of the other key features I have listed down is on the JDBC improvement. So they have improved the legacy JDBC ODBC bridge, which was there from day one when the Java came into existence. So that has been removed. So JDBC ODBC bridge, if you're not aware, that was used to connect my Java program to a Microsoft database. ODBC is a connectivity bridge which we configure on the Windows machine, and my JDBC driver used to communicate with ODBC to communicate with database. This was a old way of doing it, so now they have decommissioned that. And they have improved some security features. So if you see, right, there were some security issues in Java. Issues, I would say, like whenever you communicate, imagine you open a connection from your application, you open a connection with the database. So once you open a connection with the database for communication, the connection is established, and there is a path which is formed between your application and your database. So in production, right, in production, your database will be in one region and your application will be in another region. Say, for example, my application code which is running on my server can be somewhere in India, and my database tables which are created, could be Oracle or MySQL, whatever tables, could be somewhere in, say, in some server which is running in US. So when I create a connection object, right, in the JDBC, we create a connection. First, we establish the connection with the database server, and then we start communicating with the database tables. So my Java code starts communicating with the database tables. So my Java code is running on a machine which is there in, say, Bangalore, and my database server Oracle is there somewhere in US. Just assume that. So what happens is, once my code establishes the connection, I will open the connectivity between my code for server which is running in Bangalore to the server which is running in US. So that connection is open until I get all the values from the database using result set and looping and all. The connection is still active. Okay, and this is the loose part where some hackers can misuse this and get those connections, or misuse those connections to hack the database servers. Okay, that was one of the this thing. So they have improved those security features by implementing some of the features which enables you to handle those things. So that is also mentioned, added in Java 8. And they've added few more features called reference cursors, where the cursors are nothing but which works on a position of an object. Say, for example, if I'm looping through, I have 1,000 records in my database, and I have looped to 100 records. I want to loop through 101 records. So I will have the cursor position as 101, and I can start from the 101 position. I need not loop from the beginning. So I can have my cursor pointed to wherever I want, and I can randomly, start looping through my records based on this reference cursors. And this reference cursor is a concept in the PL SQL also, where Oracle also supports this ref cursors. So there are a few other features of JDBC 4.2 features which are added, but these are the key features which is highlighted. So you will learn all these additional features when you actually get into the details of this course. And then we have this pipeline and stream. So here we have two types. So basically, whenever we want to process the objects, right, which is there in the collections. So before Java 8, we used to sequentially process these objects. Sequentially means one by one. In Java 8, it provides a facility to parallelly process the objects. Parallelly means I can run two streams where which one stream will be working on one set of objects, and parallelly it will be working on another set of objects. This will definitely improve my performance, right? Say for example, in a collection, you have 100 objects, and to loop my 100 objects and to perform some operation on that, say for example I take 100 seconds. Instead of that, if my business supports that I can run 50 objects parallel to each other, then I can complete my job in 50 seconds. I can loop through all the 100 objects, or I can process all the 100 objects within 50 seconds, because one thread will be running and working on first 1 to 50 set, and 51 to 100 there will be another thread which will be working on those objects. So this enables the performance benefits. So that's what it is added in Java. It's a new feature. And then this Nashon. So this is a very important feature. This was discussed for a long time actually. But, Java wanted to introduce this feature from the long time, because Java had a threat, or they felt a threat because of the JavaScript. So people started liking more JavaScript compared to Java, because JavaScript is a very lightweight and a very loose kind of a programming language, where you don't have all this hard coding to be done, but it provides a very fast. If you work on JavaScript, you know it's a scripting language which provides similar to Java. The syntax and all is similar to Java, but it's more faster to code compared to, you don't need to write a class and all, it's a very loosely coupled language, scripting language, right? So there were a lot of JavaScript was growing heavily actually. So from starting from 2010 onwards, JavaScript got a very good growth in terms of its support, whether it is Ajax, asynchronous JavaScripting from the web-based applications. JavaScript became a heavily used scripting language. And now you see a lot of frameworks, the web UI frameworks, which is developed using JavaScript. And also JavaScript was mainly used for client-side scripting language. When I say client-side, it is on the UI side, web, the presentation layer side. Okay. But also JavaScript started making its path to the server side also, which was threat to Java, because Java is very strong in the server side, and JavaScript was very strong on the client side. So if you're not aware of the client and server, so client is nothing but a front end layer, what you see, the presentation layer, HTML and all those things, that we call it as a client. And the business logic, once you submit something from the client web page, when you submit something, the data goes to a server, right? And the data needs to be processed in the server. And that the language which is used on the server side is a Java. Java was heavily used as a server-side programming language, whereas JavaScript was heavily used as a client-side programming language. But over a period of time, 2010 onwards, JavaScript also started venturing into the server side also. So they started writing JavaScript code, or developing JavaScript code which can be written in the server side. This was a threat to the Java, because Java was heavily sitting on the as a beautiful language for my server side, but JavaScript also started making its path on the server side. And there is a very good JavaScript language, or technology called Node.js. Node.js is a JavaScript server-side scripting language, which is used as a server side. So this was a threat to Java, and Java wanted to introduce this Nashon, which is a JavaScript engine, way back before Java 8, but there were a few issues, and they were successful in introducing this in Java 8 onward. So this gives the capability for Java to run your JavaScript code on the server side. JavaScript can be easily run on the browser, you all know that, but now JavaScript can also be run on the server side. So any questions before we move to the next?
Deepak, I have a question. Can I ask?
Yeah.
Yeah, Deepak, when we say this on the server side, what does a language like? Because nowadays we are seeing a lot of full stack developers who like mean stack or lamp stack.
Mm.
So, does server side mean it includes things like MongoDB or what we see as Apache Tomcat at that level, or server side means only the logic which connects the UI to the database? How does it
Yeah.
like?
So server side means like say in the mean stack, right? Mean stack N stands for this Node.js, which is a server side scripting language. So basically, once the data is sent from client to the server, we need some program sitting running on the server, whether it can run on the Tomcat server or any of the server. I need a program to be running on that server which will accept the data and have some business logic to process that data. So for that we need a programming language, and Java was heavily used programming language. Java is heavily used programming language, to process that data, whether it could be a microservices in today's world, or it could be a REST-based or a SOAP-based web services, and it could be any other. So MongoDB is a NoSQL database which will store the data, and Tomcat, what you told, is a server which will run my code. So I can have the JavaScript scripting language also running as a server side, as part of Node.js, or I can use this Nashorn, or I can write basic, Java J2EE kind servlets or JSPs or any other thing as a server side language.
Okay, okay, okay. Got it, got it, got it. Yeah. Thanks.
Yeah. Okay, so and one of the other thing which I wanted to touch upon is on the Java virtual machine. As I was telling, right, JVM is a very key part. I see most of the people who work in the industry miss this touch of JVM. And always, if you don't have the right knowledge of the JVM, Java virtual machine, you will suffer in. You will write the code, but when some problem occurs on the code, you will struggle to fix that code or to analyze that issue what we have in the code. So it's very important to understand how the JVM is placed, and what are the key things, how the code is compiled or executed in the runtime, for us to write a better code. Okay, so this is just few words. I want to explain how the JVM works and how JVM 8 is different from other. So JVM, as you know, there will be all the objects. When you create objects, right? You just create an object, but you will not know how these objects are allocated on my virtual machine, right? So any developer, if I give you a program, say I ask a developer to accept two values and then add two values and give me the result. So what the developer will do, he will write a program to accept the values for variable A and variable B, and puts a formula C is equal to A plus B and prints the answer, right? To make it more object oriented, he will write a class, create a method and create an object and all. So, but once you create an object, what happens inside the JVM, right? So object needs a memory, correct? So the memory allocated inside an JVM, the object is allocated inside that memory, and then there should be a mechanism to clean that memory whenever that object is not used. So we have Java has something called garbage collector. We call it as a GC. So Java runs this GC very frequently to clean all the unused objects. So a good programmer is the one who takes care of. See, a programmer, what he does is he creates objects whenever he wants, and he starts calling the methods and all. But when once you understand the JVM architecture, a good programmer will think whether that object is required or not, because there is a cost, right? Once you create an object, it needs to be allocated or stored in some memory, and then once it is stored in memory, you will have some space used by that, and your GC has to work over hard to clean that object and all. So it's very important for us to understand how the memory allocation is done, so that you take care of when you're coding, how better you can code to have a better code. So from some of the words I want to touch upon is called the young generation. So if you see, the young generation is a place where all the new objects are created in this thing. So when you create an object, it gets allocated inside this part of the memory. So we will call it as a young gen. Young gen is a part of the memory which stores your objects. I create an object, say A is a class. I create an object, A OB is equal to new A. That's how I create an object. And that object gets stored inside my young generation in my JVM. Okay. And in whatever objects are stored in this young gen, right? So the garbage collector which will be running comes to the young generation memory and sees whether that object is being used or not. If it is being used, it keeps that object. If it is not being used, it releases that object or deletes that object. Okay, so that we call it as a minor GC. Minor GC is a minor garbage collection which cleans the unused objects which is stored inside the young gen part. And then you have this, say for example, the GC comes here and sees whether the object is being used. Yes, this object is being used, it will not release, it will keep. Second time it comes, yes, one object is being used, it will not release, it will still keep. So multiple times it sees this object is not left, means it is still being used. So what garbage collection or what JVM does is it moves this to something called old memory. So if it is available, it will clean it. If after multiple tries, if it still sees that the object inside this young gen is still being used, the object is moved to the old memory. Okay, and all such objects which are collected in the old memory, you need a major GC to happen to clean those objects. So major GC can happen every 30 minutes or every 40 minutes or every 1 hour based on your configuration, and your major GC looks into this old memory, and if this object, it releases or cleans up the objects which are not used and this old. So major GC is a heavy operation. Okay, so if you are making use of a long-lived objects, if you are accessing the objects for a longer time, then you will have a performance impact, right? When you're writing a code, if you are holding the object for a longer time, or if you're making use, say for example, I write a loop which iterates thousands or 1 lakh times. Inside that loop, I use an object, and that loops takes say 30 minutes to complete, for example, and till 30 minutes your object is being used, so your garbage collection cannot release that object from Eden space, it moves to the old memory space. So it requires a major GC to happen, clean those objects. So when you're writing the code, you should take care of whether you're having or creating such long-lived objects, because it will impact the performance of your application. So why I'm telling this is, in Java, you have something called the perm space. Okay, so we'll touch upon this permanent generation. Okay, so permanent generation is a space. So when you create a class, right, class will have some kind of information like metadata. When I say metadata, your class features, right, what all functions it has, what all variables it has, all the details of that class is stored inside a permanent generation. Here in this diagram, you see this perm space, right? Here all the class information is stored. Okay, now what was the issue in the Java before was, this perm space was very less. See, you to store the features of the class, right, the variables, functions, the references and all, so you don't need a much more space. So Java was allocating a very small space for this perm space, and always it used to result in an out of memory exception. So in Java 8, this concept is not there. There is nothing called the perm space. Instead of perm generation, they have put something called meta space. So what this meta space is, it gives more flexibility. You can allocate more memory for this meta space, and it can hold more values inside the meta space, and it gives you more advantages compared to the perm gen space. Why I'm saying this is, if you have worked on any Java projects, you would see a famous error called out of memory error. So if you have worked on any of the real-time projects, definitely you would have seen this error called out of memory error, which in your lifetime, one or the other time you would have seen this. This out of memory error was happening whenever the permanent generation was full. Whenever the permanent generation space gets filled, it results in an out of memory exception. And this is a very costly exception because it brings the entire production down. All my server will fail because of one this error. So that is being avoided in Java 8 by making use of meta space. So this is a new concept which is added in Java 8. Okay, so we'll talk about, in the course we'll talk about more on this JVM architecture, and we'll see how it is structured, and what are the more advantages and more features when it comes to the JVM part. Okay, so just I wanted to touch on this JVM of the PermGen getting converted into metaspace in Java 8. Before that, I wanted to give you a few background of JVM and the architecture, so that you guys understand how it is architecture and what are the changes in Java 8. So any questions on this before we move? You guys are understanding, are able to get a very high level picture? Okay, so let me know if you have any questions, otherwise I'll just move to the next one. So I'll quickly touch upon some of the design patterns which we strongly use in the industries, right? So we have, whenever a design pattern, what is a design pattern? Design pattern is nothing but an industry standard. Okay, an industry standard, a proven way of making things work. Okay, so in simple terms, if you want to put, a proven way of making things work is called a design pattern. Right, so in our lifetime, in our normal day life also, if I have to do any work, right, if there is already a proven way of things happening, then it becomes very easy for me to complete that work in a faster way. Similarly, in our programming world also, instead of just going and writing the code, if there is a proven process and a work or a structure where how I have to code, how many classes should be there, how it should be structured, if there is a well-defined process or a pattern which is recorded, it becomes very easy for me to code. So these are all the based on industry, all the successful projects. They have collected the case studies or best practices of all the successful projects, and they've created something called design patterns. So at a high level, design patterns are categorized into three: creational pattern, structural pattern, and behavioral pattern. So I'll not go into the details of these patterns. In case you guys have any questions, you can let me know. Creational pattern talks about the new things, like say for example a factory pattern. If I take an example of a factory pattern, like say for example, if I have to create an object, right? So if I have to create an object, it will hide those object creation activities from me. Like say for example, how easy it will be, like if I have to go to finance department, or if I have to go to some advertisement department, and if I want to go to some educational department, for example, instead of me contacting that finance department guy and getting help from finance department, and me going to educational department and getting help from, if I have a person who does the job for me, I will communicate with that person, and that person will communicate with the finance department or the educational department or the advertisement department. So for me, it will be very easy for me to handle things. Instead of communicating with three people, I'm communicating with one person. So that's what factory pattern talks about at a high level. Okay, so it generates, factory is what? Generating something. What it generates what you want, right? So that's a factory. So if I have one person who generates an education department contacts to me, which generates functionality, finance department contacts and gives it to me, and if it generates advertisement department contacts gives it to me, it becomes very easy for me to communicate with that person. That person which I'm talking about, I will call it as a factory. A factory. Okay, so this is a factory pattern. And in structural pattern, if I want to take an adapter pattern, you take an example like if I take my charger from India to US, my the pins will not hold or will not fit into US sockets, because that has a different design, right? So US sockets is a different design, and our in India it's a different design. So the charger plug which fits to the socket in India will not fit to the socket which in US. So to fix this issue, what I'll do is I'll take one adapter in real time. So adapter will have a converter which takes the input as an Indian socket, and which will fit into the US socket also, right? So that's, I'm just mapping to the real-time example so that you guys understand what's this concept all about. Similarly, in Java, we use adapter pattern to fit things into multiple places. So I write one code, and if it doesn't fit into some other places, I will not change the code. What I'll do is I'll write an adapter pattern. Adapter pattern will take my code and makes it fit to the target code. Okay, so that's all about the adapter pattern. And in behavior pattern, you have iterator pattern. Iterator is iterating an object. And observer pattern. Observer pattern is like you will be observing some objects, the behavior of some objects, and then if there is any change, you will trigger an event. Like say, for example, I'll be observing the behavior of some object, in a finance. Say, for example, if the value of some variable is goes greater than 1,000, then I want to take some decisions. So I will have some objects which will be observing that, and once that value reaches 1,000, I will take some decision. Then I can write some code to call something, and take some decision based on those values. So you have a lot of patterns. I've just taken few patterns as an example to touch upon, but we'll be learning on all these patterns are used in industry today. Okay, so not only this, there are several patterns which is widely used in the industries to make our job easier and to write the code in a better way. Okay, so any questions on this? Anything you wanted to ask or talk on this? Okay, so best practices, quickly touch upon. Again, we'll be talking all these things in the course, but the best practices always, why I took this slide was you guys should understand whenever you're writing a code, it's not just writing a code. It's the question of how well or how good you write the code. So whenever you write the code, you have to take care of coding standards. So Java defines some coding standards, right? You have to have such and such cases, and the lines of the function methods, and also that basic coding standards. And you also should take care of memory management. Okay, so writing code is not a great thing. Writing a good code is very important. So when I'm writing a code, if I think of how the memory gets managed, if I create an object, how the memory gets allocated to that object, will it be garbage collected? Will there be a performance impact? So writing, thinking of, and all those memory related aspects. For this, you need to understand the JVM well, Java Virtual Machine. Okay. So first thing is you have to follow the right standards. You have to think of how the memory management happens and write the code to suit the lesser memory footprints. Lesser memory footprints means if you just go on creating thousands of objects, your application will crash. You have to see how less objects you can create and how you can reuse those objects, instead of creating new objects, because creation object is a costly operation. Okay. And performance, you need to also think of when you're writing the code, you should think how it will perform. So I can write a code which will run in 10 seconds. I can write the same code with the same functionality, for the same functionality in a different way. I can write the code which will complete in 1 second, right? So it's very important for you to understand the performance related aspect when you're writing the code. Again, for this, you need to understand the Java virtual machine well. And security related, you need to think whether your code is secured, whether it complies with all the security standards and all. We will and also the Java virtual machine layer, which comes to, like, say for example, I gave an example of JDBC. I've seen many people who writes the JDBC code, who opens the connection and gets the result set object and starts looping to the result set object. So if you guys have heard about the result set object, the result set object is an object which we get from the database, which contains the records, right? Once you get the result set object, the connection is still open. Till you loop the result set object, the connection is established with your database and it is vulnerable for any hacking. Okay, so you need to understand when you're writing the code whether you're writing in a very secured way or not. Okay, very important. And write better user experiences. So you need to understand basically in a web application, right? When you're writing, whether it is giving a better user experiences and all, you have to write the right way. And also the debugging. Okay, so you need to know how to debug the code and how to what are the tools used to debug the code, how to fix a problem. See, writing code is not tough, but after writing code, if there is a problem which occurs, then to identify the problem is a very key thing, and it requires a separate skill set. Identifying a problem is not easy. It requires separate skill set, and it requires separate tools to identify the problem. Once you identify the problem, you can fix it. But the identifying the troubleshooting, right, the debugging part of the problem is very important. Okay, so why I covered this is you need to understand not only writing the Java code, but how good you write the Java code, taking all these aspects into the consideration. Okay, so and the last thing, I think we're running out of time. On the last slide, I wanted to cover on some of the industry-based troubleshooting and debugging techniques. So usually, whenever we see a problem which happens, the first thing what we will do is go into the log file. A log file contains all the details of the executions which has happened in my program, right? So it could be a server log or an application log. And we also go into the debugging mode to find out where the problem is. If the problem is not found there, I cannot find a problem in the log, I don't see any symptoms in the log or in the auditing log or in the debug mode, I don't find that problem, then I go to the next step. I go to the thread dumps. Thread dumps is something which your JVM. Okay, so within when you run a Java code, right, it creates multiple threads. So we will take a thread dump. Thread dump means we will take the thread logs, the Java thread logs we take. So if you have heard about Java multi-threading and all, internally Java uses a lot of threads to execute our programs. So it generates some logger files also. It generates some debugging log files which we take the thread dump logs and try to analyze, is there any problem with the threads which has got created, any thread has got stuck, or any thread is running for a longer time which is causing this problem. We will analyze that also. And so basically thread dumps are analyzed when we have a CPU problem. Say I'm running a code and CPU is reaching 100%. I don't know what is the problem. Why my code is taking 100% of the CPU? You know, right? Once the CPU reaches 100%, your system, your server will crash. So if I have to understand why my program is taking 100% of CPU, analyzing thread dump is the only thing. Okay, and my CPU is okay. Now for my another problem, my CPU is okay, but my memory is growing. I have a 8 GB RAM, and it has utilized all 8 GB RAM, and but it's still not fine. It is still crashing because my memory got to expire or over. My memory got full, and when I stop my program, the memory comes down. When I run my program, the memory goes to 8 GB and my program crashes. Why is this happening? To investigate, we need to take the heap dumps. So heap dumps is again at Java virtual machine related created log files. which helps us to analyze why my program is taking huge memory. That's what I told in the previous slide. You need to take care of all those factors when you're writing the code: memory, performance, CPU, and everything, so that we don't end up in such situations. But usually in production, we end up in such situations because of some developer who have not considered that and written a wrong code, which will cause all such problems. And we need these, debugging techniques and tools to analyze and debug those issues. So, and then the GC garbage collection. GC garbage collection also generate some log files. So we need to check those log files to see whether the garbage collection is happening fine, and garbage collection is taking more time. If it is taking more time, why it is taking more time? What is the object which is it is not able to clean? And those issues we have to debug, and we have to see what code is causing that problem, and what is, see, if the garbage collection is not able to clean an object, it will keep on trying, and it takes a lot of CPU cycles. And we have to go to the garbage collection logs to find out the root cause and fix that issue. And you have the DevOps tools. DevOps is a separate topic which we can cover in the sessions, the course. We'll use a lot of DevOps tools to make all these jobs easier for monitoring and reporting and execution of the project. And again, the performance. So this is a key aspect. So performance related debugging is a separate expertise altogether. If you want to make sure tune the application for the performance, you have a lot of tools and debugging techniques to understand the performance issues and perform the code changes accordingly. Okay, so just covered about the very high level things of how you should prepare yourself for your industry if you're working on a project in a company or in an application. So what are the things that you need? It's not just only writing the code, it is too many things which you have to consider to write a very good code. And also, it's not just writing the good code. If an issue happens, how you approach that issue and what are the measures or the techniques that you will use to fix those issues is all what we need to understand. So just try to cover about a very high level on these aspects. And if you guys have any questions, we can take up the questions.
Yeah, thanks a lot, Deepak. The floor is now open for questions, guys. So any questions on the session which you have, you can drop it on the chat window, or you can unmute yourself and ask Deepak. So maybe if Lakshmi, Ankit, Jagannath, Mahindra, Gashet, Ayodhya, any of you guys have any questions? You can.
Yeah, no question.
Okay.
I hope you guys were able to understand because I covered a little bit on a very cream level, but if you guys have not heard about some of the words, because I assume some of the words you might be aware. In case you guys have not heard about some words which you were because of which you are not able to understand what I spoke, you guys can ask even that also.
Deepak, a little bit about how this, how much of depth or what the full-fledged course is all about. Like, are they going to be getting a little bit of an insight from the beginning, or do they need to, like, if they're taking up the course, do they need to have a certain inherent idea about any of the concepts? Like, so a little bit about that would.
Yeah. So in the course, how the course is structured is it will cover the basics of Java core programming, and then it will cover the advanced core programming Java features. And the advanced, when I say advanced core Java programming features, multi-threading and exceptions handling and database connectivity and all those things. And then we will talk about how all these last couple of slides which we covered, right? How you write a good code as per the industry standards, best practices, design patterns, frameworks which we use in the industry, and the debugging techniques, tools, the JVM architecture, how to keep in mind those memory footprints when you're writing the code. Because what we have seen is in the industry, the developers who learns core Java, they will have the programming skills to write a code, but they will lack the debugging and the troubleshooting skills, number one, and number two, writing the better code. So they write code which will go and fail in production at some time. It will be working in all the test environments. The unit testing will pass, the system testing will pass, the acceptance testing will pass. But when it goes to production with a huge load which comes in, it fails. So we also have the things covered in the in our course which talks about how do we take care of writing a better code in order to avoid such features, issues in the production code base.
Yeah. So guys, if you're interested in going through the full-fledged course, or you want to enroll for the same, we are planning to, these will be weekend batches. We'll be conducting them in a couple of weeks from now. So the details for the program is completely given on our website. So you can go on to the website and maybe check the course under Java 8. I'll be putting the course URL up on the chat window. We'll be sharing a mailer also, which will be having these details. So yeah, if I think no one has any questions. If you guys have any questions, please do let us know, or else I think we'll be wrapping up today's session. Anyone has anything else you want to ask or check out?
Yeah, could you please complete brief introduction, brief details about the course structure and timings, everything. We will decide it is possible to join us or not.
Yeah, Lakshmi. So the course is going to be a weekend course, and the timings we are seeing, we are looking at a timing of 8 hours per day, or 4 hours per day, because all our courses are scheduled. So once we are going to be finalizing the dates with you guys and the trainers, we'll be deciding whether the flexibility is for an 8 hours per day kind of weekend session. Then you'll be having it over a single weekend, because it's a 16 hours program, and after that you'll be having hands-on. Is that is the way we are going about, then we will let you know. Or else we'll be having 2 different weekends in which we'll be putting it as 4 hours each on a Saturday, Sunday, Saturday, Sunday. So this will be the format in which we'll be structuring the program. In terms of the course content, you'll directly find a detailed course content on the website itself. I'll be sharing the URL with you guys.
Okay.
And the pricing and other details as to what else we are providing along with the course, like the course material or the post course, if we are providing any kind of placement support, or if we are providing any kind of other material, and you'll be having lifetime access to video